So this is the hands-on section for the section on multidimensional arrays, specifically two-dimensional arrays. We're going to be using those in both examples. So this is the first one in which we simply initializing a two-dimensional, three different two-dimensional arrays in different ways and printing out their values using this print array function, which has these two nested for loops. So this code is unchanged from what you saw in the slides. It's almost the exact same thing minus the comments. So this is array 1, all of size 2 by 3, all of dimensions 2 by 3. So this is the one which we're initializing fully, in which we're initializing every element. So 1, 2, 3, 4, 5, 6, and printing it out using the print array function, which we have defined further down after the main function. Then we have the integer array 2, also same dimension, but this one we're kind of initializing, like we're treating it as a one-dimensional array. 1, 2, 3, 4, 5, 6. So 4 and 5 are actually elements of the second of array number of row number 1, while 1, 2, and 3 are assigned to elements on row number 0. And then we have array 3, in which we're partially initializing only the first two values of row number 0 and only the first value of row number 1. So let me run this. And there you go. I'll put the output side by side with the code. You can see array 1 is initialized to 1, 2, 3 for the first row, 4, 5, 6 for the second row. By the way, this printing out onto two lines, this is not happening by accident. The print array function is taking care of that for us. Take a look. We put a new line character after going through the inner for loop. So this /n character, that's what's breaking across these lines. That's what's causing the output to show as different rows. If I didn't have this over here, these values will just show up on one single row. Yes. Save this. And no. So let me run that with printf commented out, and there you go. Kind of a mess. Okay. And you could just use a put statement, an empty put statement as well. The purpose here is only to insert a new line after we're done printing out each row from the array. And over here you can see how we're actually accessing each element: A, I, J, row index, column index. And let me also show you how what arrays look like in the watch window. So I'll just put a breakpoint over here on one line. So by this point, we will have defined array 1, array 2, and array 3. So let me run that. Okay, so the code is stopped. And you can see over here, so array 2 and array 3 are visible at this place. Array 2 can be expanded. You can see I can see the elements of the first of row 0, 1, 2, and 3, and the elements in row 1 as 4, 5, and 0. And then I can further expand if I want. I can further expand each row into separate values. So row 0, column 0 has integer value 1. Row 0, column 1 contains value 2. And row 0, column 2 contains value 3. So you can really open this array up, and you can do that. If you had further dimensions, you could open up each dimension like that. So this is how you can monitor arrays. Or if you don't want to click through that, I can see it right over here. So this is over here. The first thing over here is the address of the array, and as you can see, that is also the same address that shows up over here, which is the address, the starting address of row 0 that contains 1, 2, and 3. And following that, we have another address that is the starting address of the next row, row 1, which contains 4, 5, and 0. And we can see similar addresses for the other array 3. Has a starting address for the 2-dimensional array, which is the same as the starting address for row 0 of that array. And then we have also the starting address of row 1 of array 3. And over here, of course, the type and dimensions of the array. Integer array of size of dimensions 2 by 3, 2 rows, 3 columns, 2 rows, 3 columns. Okay. Let this run. Take off the breakpoint over here, and now let me jump to the other example. So this is the one with the student grades. And in this one, I kept all of the comments because I want to show you something else. So I already discussed the code itself. So there's nothing else that I have to add to that other than, of course, running it, showing you the output, the same that you saw in the slides. So we first start in the main function by calling the print array function. And that print array function very nicely prints out all the elements of this 3 by 4 array, adds these nice strings in front of each row, and adds these nice column headers before printing out any of those values. We then call the minimum function and the maximum function and print out the lowest grade achieved by any student in the semester and the highest grade achieved by any student in the semester, in any test in the semester. And finally, we have a for loop in the main function in which we go student by student and basically row by row of the student grades array, and we compute the average test score of each student that semester. And we also pass, of course, the number of exams we had that semester. So the length of the row, we pass that to the average function as well. And the functions, all of those functions are defined right underneath. We have the minimum function, the maximum function, and the average function, and the print array function. So I mentioned I did something slightly more elaborate this time. I even included all of the comments that you saw in the slides, and for a reason. So something nice that you can do with Visual Studio to make your code more readable, more understandable, especially when it starts getting bigger like this one. You can see this 108 lines of code. Okay, so see that I roughly, so before each array, so there's only one array that I'm defining, the student grades array, the 2-dimensional array. The line above that, immediately above that, is a comment that describes what this 2-dimensional array is. Initialize student grades for 3 students. Okay, and just like that, I put a line comment right at the start of each function. So function main begins program execution, and then right above the minimum function, find the minimum grade that kind of describes what this function does. Find the maximum grade above the maximum function, and then above the average function I put a comment that says determine the average grade for a particular student. And then above the print array function, I put this comment. So something nice that happens when you put comments above or on the same line as a function or a variable. Let me show you. So I am calling these functions over here in the main functions a little bit. I mean, I have to scroll down to actually see the code of the function. But look what happens when I hover with my mouse over one of these functions. So for example, minimum. So you see it gives us in the first row, it gives us the function prototype. Integer minimum takes a constant array of size 4, etc. All that. But right underneath that, check the second line. Find the minimum grade. That is this comment over here. So if you put a comment above, in the line above where you're defining a function or a data or a variable, or even later on, right to the right on the same line as the line of code. What Visual Studio will do is it'll treat that as documentation. It'll display that comment like this in a in this hovering bubble. So let me show you the same thing for the maximum function. The maximum function is being used on line 29. See, the first line that we see is the function prototype, but after that, find the maximum grade. That is the comment I put right above the definition of the maximum function. So that is quite handy. It can make it, if you follow this as a rule, if you do your commenting like this, and maybe you're looking at a large piece of code, a large source file, you can simply hover over a variable to see what that variable was. If you put comments right before that. So for example, student grades, I put this comment above it. Initialize student grades for 3 students, rows. Let me hover over student grades anywhere in the code. See, initialize student grades for 3 students. This is that comment that I left up here. So I can see that anytime I hover over student grades, any place in the code. Very handy. Okay. What else? Oh yeah, here's another variable, high grade, and I put the documentation for that on the same line as the definition of the variable high grade. Check this out. Initialize to highest possible grade. The comment I put on the same line over here, so I can see that anytime I hover over high grade. And I think I did the same thing for low grade. I put a comment on the same line, works the same way. Initialize to highest possible grade. This should actually be lowest possible grade. So let me try that again. There you go. Initialize to lowest possible grade. I just copied, pasted the functions and made changes. Forgot to change the comment. Okay, and that's all about the hands-on section for multi-dimensional arrays.